So we're going to go over the review for the Unit 1, sort of the Unit 1, with the chemistry and biochemistry exam that you'll be taking soon. And it's not really Unit 1 anymore because we did ecology first. I guess it's Unit 2 now. Okay, chemistry section. Distinguish between reactants and products. Okay, so when you have a chemical reaction, oh man, it's not working like I thought it would. Okay, look at that. I knew we could do it. Okay, so when you have a chemical reaction, like for example, A plus B gives you C, the things you start with are the reactants. This is behaving weird today. I don't know where the pencil is. And the things you end with are the products. So let's look at a real example. So let's look at maybe hydrochloric acid. That breaks down into H plus Cl minus. So the reactant would be this, and the products would be that. Here's another one. Let's see. Let's take CO2 plus H2O, and that makes C6H12O6 plus oxygen. And if you want to balance it, there'd be a 6 here, and a 6 here, and a 6 here. Okay, the reactants are the things you start with, and the products are what you produce, the things you end with. Okay, what's an ion? An ion is a charged particle. So for example, an ion could be this thing, H plus, or it could be Cl minus, or it could be OH minus, or it could be Na plus, anything that's charged. And so the way that you get a charged particle is by gaining or losing electrons. So you can write that part in. Make ions by gaining or losing electrons. And so the mistake that students will make sometimes is excuse me, is they'll say, well, maybe you can gain and lose protons because those are charged too. And an ion is defined, another way to define an ion is by saying the number of protons does not equal the number of electrons. Like in a neutral atom, like carbon, for example, there are 6 protons and there are 6 electrons. If you look at an ion, that's not true. Sodium, for example, has 11 pluses, and when it's an ion, it has 10 minuses. So if these aren't equal, you get a charged particle. And you get that by gaining or losing electrons. You don't get it by gaining or losing protons, because if you do that, you don't have the same element anymore. So sodium, for example, has 11 pluses. Whoops, pretend that's an 11 pluses. If it lost one of those 11 positive charges, if it had a nuclear breakdown and it lost a proton, it wouldn't be sodium anymore. It would only have 10 pluses, and actually it would be a different atom. It would be neon. So the protons are actually much more telling about the element than the electrons are. The electrons can change, but the protons definitely cannot. Okay, so next one, number 3, distinguish between ionic and covalent bond formation, which stays together in water and which dissociates. Okay, so an ion is when you have two different ions. An ionic bond is when you have two different ions that come together, a negative one and a positive one. And when they come together, that's an ionic bond. Covalent bonds happen when you share electrons. Whereas a way to say it for ionic would be that they transfer, or they give away or take up electrons. Transfer electrons. Notice we're still talking about electrons. You don't share protons. They're stuck in the nucleus. So for transferring electrons, sodium gave its electron to chlorine, and so they're ions now. And that would make an ionic bond. Covalent bonds is when they share electrons. So for example, you've got hydrogen. Let's do it this way. Hydrogen has 1 proton and 1 electron. And you have another hydrogen atom with 1 proton and 1 electron. And this one needs 2 to fill its outer shell, and that one needs 2 to fill its outer shell. And if they both come together, they can share those 2, and the electrons will go around both. So sharing electrons gives you covalent bonds. Another way to remember it is co means that there's 2 that are working together, like with co-teachers, both of them work to help you learn. Veil, this is maybe a little bit lame, but hopefully it'll help you remember. So here's a lady who is sideways by accident, and she's all happy because she's getting married, and you can't see her face because she has a veil in front of it. So sometimes a woman will wear a veil when she gets married, so that might help you remember that this is a strong bond. So covalent bonds are very strong. Which stays together in water? That would be covalent. When you share electrons, water can't break that apart. Which dissociates? Another word for dissociate is to come apart. And the one that comes apart in water is ionic. And why that happens, the reason that happens is water can squeeze right between them because water is more attracted to that and to that than it is to it's to itself even. So here's a sodium and water. Let's see, the negative part of water will be attracted to the positive charge here. So it'll look like this. And if you look at chlorine, we'll draw that over here. That's an ion as well, but it would be the hydrogens that would be near it. It would be the positive side of water. So I'm trying to draw hydrogen ions there, like that. Okay. Distinguish between polar and nonpolar covalent bonds. Okay, so with this one, they are still both covalent, so they're those strong ones that don't come apart. The difference between them, think polar is opposites, and opposite would be something that has a slightly negative charge on one side and a slightly positive charge on another. So water is polar, and the thing that's happening with this is that you have a slightly negative charge on one side, slightly positive charge on another. So the electrons are not shared evenly. It's a little bit lopsided with the electrons spending more time with the oxygen. If you look at nonpolar bonds, nonpolar covalent bonds, that would be what oxygen will do with oxygen. So oxygen has 8 pluses, so it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. And here's another oxygen with its 8 protons, and it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this one needs 2 more. It has 2 lonely electrons, and that has 2 lonely electrons. So these will share this pair and this pair. And the thing is, who's going to pull harder on the electrons? David just joined me. David, would this oxygen with its 8 pluses pull the electrons harder, or that oxygen with the 8 pluses? Nothing wise. Go ahead.
They both will pull the same.
Good. And that's called nonpolar. That's nonpolar because they're both pulling as hard, so it's totally even pulling, even charge distribution, or even sharing. So polar is like water. Anything that's polar will mix with water. Anything that's nonpolar will not mix with water. So you can also put hydro.
So oil is nonpolar?
Oil is nonpolar. Hydrophobic for this one.
Wait, so oxygen doesn't mix with OH?
Well, here's the thing. It's tiny enough that it actually will mix. But if it were a big molecule like oil, then it wouldn't. So that's a very good question. Hydrophilic. All right, so what else did I want to say about these? Oh, one more thing. So I had students really, really having a hard time between figuring these out. And so I had a kid in, I want to say it was my C period class, figure this out for me. So here's a guy. What? I don't know what just happened. Here's a guy, and he's...
Wait, no.
What's happening?
No.
All right, I'm going to pause this.
No, that is horrible.
What's horrible? Inserting as image to Word. David, what's wrong?
No.
Can you relax?
Why is this not working? It's going to put in all those images into the document.
That's okay, because I saved it with answers. It's no big deal. I don't care. Except that it's
No, it's going to put in all the pictures that you've been drawing.
I don't care. I saved this is something different. It's not my real one.
Okay, alright.
Thank you, though. I want to draw a fishing pole here. I think it was Ethan who figured that out for me. And I can't draw because it's doing this thing.
Just
all right.
Pause it.
I'll pause it. Bye.